So this is our first problem we are going to handle in work done in springs. Work done in springs. All right. Now, a spring is 1 meter long when unstretched. Right. It means its original length is 1 meter long. So we know its length here is 1 meter. Okay, I'll use a clearer pencil here. All right. Now it exerts a force of 10 Newton when stretched to 1.2 meter. So it has a force of 10 Newton. All right, when it's stretched to 1.2. So when it's stretched to 1.2, so L2 here. L2 here equals to 1.2 meter. So L1 is 1 meter, L2 is 1.2 meter. Alright, we are required to find the work done required to stretch the spring from 1.5 to 2 meter. Alright, so we need to do this. The work done here is stretching the spring from 1.5 meter to 2 meter is the integral of the force function over the interval of the extension A to B. Alright, so in order for us to find the work done, we need to first of all get our force function there. And our force function f of x is equal to the spring constant times x. So this f of x is equal to the spring constant times x, right? So we can equally write this formula as this. All right, we can equally write it as this. All right. So let's. But there is an information missing here. We have our force. We have. Do we have our x? Yes, we do actually, because our x here is actually equal to L2 minus L1. X here is the extension. So that's 1.2 minus 1 meter, giving us 0.2 meter. So with this information, we can get our force, our spring constant here. So f of x equals to k times 0.2. Right? So remember, we already have our force to be 10. So 10 here equals to 0.2k. Okay, we divide both sides by 0.2. Then we have our k to be 50. 50 watts is going to be 50 Newton. Force is in Newton. Extension is in meter. Newton per meter. All right, so we already have this, so we can write our force. So all we need to get our force function is the value of k. So our force function is f of x equals to 50x. That's our force function. So we are plugging that into the integral there. So it means w equals to 50, all right, 50x dx, right? 50x dx. Now it's over what interval? Now we're trying to find the work done over what interval. We want to find the work done required to stretch the spring from 1.5 to 2 meter. So the interval we are talking about is from 1.5 to 2 meter. All right, that's the interval we're talking about along the x-axis. So W here will be equal to getting that's 50. We're trying to integrate that 50x squared over 2 to 1.5. All right, so we can so W here equals to 25x squared. All right, 25x squared over this, so we can just plug that in. So that'll be 25 into 1.5 or 2 squared, the upper boundary minus the lower boundary, which is 1.5 whole squared. All right. Okay. So 2 squared is 4. 1.5 squared is 9 over 4. It's 9 over 4. That's about 2.25. So W equals to 25 times, this gives us about 1.75. Now W, which is our work done, will be equal to 43.75, right? We can express it as joules here. So 43.75 joule.